This Week in Microbiology is brought to you by the American Society for Microbiology at asm.org/TWiM. This is TWiM, This Week in Microbiology, a special episode recorded on June 9th, 2018. I'm Vincent Racaniello, and you are listening to the podcast that explores unseen life on Earth. Today we are recording at ASM Microbe 2018, a meeting taking place in Atlanta, Georgia. My guest is the president of the Warhol Institute, John Warhol. Welcome to TWiM.
Hi, I'm thrilled to be here. Nice to see you.
And this is happening because I met you maybe 2 months ago at a conference at Seton Hall, right?
At a conference at Seton Hall. And I was invited to talk about our activities in getting an official state microbe for New Jersey.
So we'll talk about that, and we'll talk about your new book, which is all about the periodic table of the microbes. But first, let's talk a little bit about you. What is the Warhol Institute?
The Warhol Institute is the name of the company that I have.
Mm-hmm.
We've been in business for 20 years, I think, as an official LLC.
Mm-hmm.
Before that, I had a company that had just my name. And I figure institute gives a nice ring to things.
It does.
I've been doing corporate science and medical communication for about 30 years. In fact, since I got out of the university, it's been what I've been doing.
You're not related to Andy Warhol, are you? You are.
The family story is that we are, in fact, related.
Uh-huh.
And I use that to advantage as much as I can.
Did you ever meet him?
My parents did. My Uncle Mike claims to have had. Our family is from Elizabeth area. The Warhols of Andy's fame are from the Pittsburgh area. And he remembers as a kid, my Uncle Mike making the trip from Elizabeth to Pittsburgh. And he remembers it vividly because he said, I got sick as a dog on the way there because it was, 1930s, 1940s, and it's a long ride. So they met and he said, yeah, let's go to Pittsburgh and play with the Warhol cousins. And they did that a couple times, but they're just too far away.
Yeah.
And then my parents met him when he was in New York a couple times. And,
Yeah. Okay.
Yeah, we're a scattered family.
So you grew up in New Jersey?
I grew up in New Jersey.
Where'd you go to college?
Rutgers.
And you were a science major, I guess?
I was a microbiology undergrad and a microbiology grad student. Yeah.
And grads also at Rutgers?
Yeah, they sucked me in. They wouldn't let me go.
Who did you do your PhD with?
Morris Solitarovsky.
Mm-hmm.
He was one of the original TB researchers.
Okay.
Yeah.
How did you get interested in microbiology?
It's a long story, and I think somebody asked me that yesterday, and I believe the answer is when I was young, when there was only 3 TV stations, one of them ran a special on someone, I think his name was Roman Vishniak, and he was a photomicroscoper.
Right.
And I think the show was called The Amazing Small World of Roman Vishniak.
Yeah, that's right.
Really? I remember correctly?
Yes, that's absolutely right.
Okay, and then it stuck in my head, and I said, this stuff is really cool. And I want to do that. And at the time, I was really young. And this is precognition just about.
Yeah.
And I just stuck with that, junior high school. And I said, I'm going to be a microbiologist. Not that you ever have a chance to do any of that in high school or junior high school.
Yeah, of course.
And it got a lot of strange reactions from the graduates counselors and even the science teachers. I was like, why would you pick that? I said, I don't know. It's just cool. I heard about it. I want to do it.
So after you got your PhD, what did you do?
After that, I had a really prestigious postdoc with the American Association for Advancement of Science. It was a science and diplomacy fellowship working with the AID, which is an arm of the State Department. Agency for International Development is the aid arm of the State Department. I was working on international health issues, ORT, maternal health, vaccine initiatives, the malaria vaccine program. I was managing. Well, you're not allowed to manage, but I was working on those kind of problems. And the reason I got into that program was because I write well. Not because I was particularly a brilliant science, but I was extremely interested in international health because I think it's cool. You get a lot of really cool diseases outside of the U.S. that you don't get here. I love parasites because they're so complicated and have the most interesting life cycles. And I went there and did that. I was the youngest fellow they had at the time. And the idea was to get mid-career scientists involved and active in the government because, as I'm sure you're well aware, most politicians and most government people have no background in science. So the AAAS started the program just a year or two, maybe 3 years before I got into it. And the idea is that you would bring people with scientific expertise and put them in the staff of a congressman, a senator, or the various outlying kind of agencies and contribute some sort of expertise to the project.
How long did you spend in that position?
It was a year. It was defined to be a year because they didn't want people hanging around.
Right.
At the end of a year, I had the chance to renew it because they signed me up for another couple months, but then I was offered a fellowship in the Rutgers, again, Graduate School of Management. So I went back under fellowship to get an MBA. I did that for a year, and then I started working in medical communications.
So you started working for companies in
well, it was it's a hidden industry out there. Unless you're involved in it, you don't know it exists. And I imagine it was different 20 or 30 years ago. Whenever a new drug comes on the market, physicians need to learn about it. So there's physician education, pharmacy education, nursing education. Somebody has to make all that. Mm-hmm. And it's really not the drug companies. The drug companies contract with medical ed companies and advertising companies.
Interesting.
So my first job was writing for a medical company.
These positions still exist, I presume.
They're out there. It's a big hidden industry.
It's a good point to make for listeners, because if you're looking for other careers besides academic microbiology, that sounds like that'd be something to look into, right?
It is. Yes, it's something you can definitely get into. What I find now in terms of medical communication as a career option, 30 years ago, because I kind of decided that I really don't want to spend any more time in my life pipetting if I don't have to. I wanted to do management of science, talking about science and communicating science. And until recently, I felt dirty because I would be, a PhD working in a communication company or an advertising agency, and you'd be interfacing with scientists, people like you. You'd be interfacing with physicians, and they say, "Oh, why aren't you in a lab? What's wrong with you?" And it's like you just always felt a little off about what you were doing. But you need to have people in those fields, like people like me, who understand the science and can put it into translatable language so that other people can understand it. Even between physician specialties, like if you have infectious disease physicians doing clinical trials on something and then you want to get it to Main Street physician, you really have to pick your words carefully because it's a different language. And then you go from there to patients and nurses. It's all different languages and different ways of addressing the issues. And I'm lucky to have skills in that area.
Do you still do this, or you stopped a while ago?
The company still exists. It's I've weaned off my client base because after doing it for as long as I have, I'm kind of tired of it. I had my big clients were Johnson & Johnson, and I did a lot of work for biotech startup companies.
Oh, so this is a company you founded yourself?
Yes.
And you had some other people working with you?
Yeah, I did. I have art directors and editors and proofreaders and researchers and other writers who funnel things through me. Because what I found is that when I was working for another company, I didn't like having a sales guy representing my work as something that he did. And I found that annoying. It's like I'm the one with the talent. I should be getting the recognition. Mm-hmm. So I freelanced for a while, and then I actually started the company so that people know when they're dealing with me that I'm the one that's writing it and I'm the one managing the accounts. It's not some third party.
So as of today, you no longer do this kind of medical communication?
I still do. I still have one or two active clients.
Okay, so it pays the bills, right?
It pays the bills, sort of, yeah.
But some time ago, you started the Warhol Foundation, which has a broader goal of communicating?
I'm working on that.
But that is your company that you're still writing for at the moment, right?
Yeah,
okay, got it.
I mean, what I'd like to do is to turn it into to start for 501c3, which would be a nonprofit, so that I can get grants from either NIH or whoever, or the federal government, because they can make grants to companies. I don't think they can make grants to corporations.
And what kind of grants would you want to get?
It would be to forward and promote science education and literacy in the U.S.
So NIH does that?
I think they do. I've been told they do.
I should make my LLC a 5013C, right? And do
Yeah.
the same thing. I don't want
Yeah.
to compete with you, but I do need to get some financial
Well, we could work
support.
together, but it's like my accountant said, you got to start making money at this, dude.
Yeah, I know what you mean. My wife tells me that all the time.
Yeah. Well, I was fortunate enough that what I was doing for a long time was profitable enough, so I didn't have to worry about making a profit for a while.
Right.
But it's like doing the periodic table and doing the stuff with the state bacteria. It's like, all right, it's time to start thinking about making money again.
All right. So now let me ask you one question before we talk about your projects.
Yeah.
You made a statement. Which is a great statement. I think it's in your book.
Okay.
You correct me. How microbiology is cooler than astrophysics, but they have better TV shows.
Oh, this is my soapbox. This is absolutely my soapbox. And I'll take a breath before I get started. Yeah, microbiology is way cooler than astrophysics. Growing up and even now, every time you put on TV, you have Stephen Hawking sitting there. You've got Morgan Freeman talking about how big the universe is, how weird it is. You have Mike Rowe voicing over these great how the universe started. You have Neil deGrasse Tyson, who is like my idol, but he's also my nemesis. I want his job for biological sciences.
We need to have someone like that for bioscience. We don't have one.
We don't have one. I want to be that. I'm willing to be up on stage in front of anybody talking about it. Because when astrophysicists talk about space, they talk about how big it is, how wide it is, how far away everything is. And I think the reason why that latches in people's minds and people relate to it is because, you're little, you look up, you see the sun, you see the stars, and it provides an inherent marketing base, an inherent audience base for everybody. You see the sun. And then the astrophysicists come and they say, yeah, the thing is so far away, and yeah, there's life on other planets. And I'm like, there's no end to the universe in a big way. But like microbiology, there's no end to microbiology in a really small way. You could study micro forever and never get to the end of it. And this meeting is symbolic of that. It's like you can't know everything about all the organisms. It's infinite. It's an infinite amount of knowledge. And it's like they have the better TV show. We don't have anybody out there talking about that. And like they're saying new things. I'm going to get attacked when I walk out of here. I could tell it's going to be an astrophysicist that's going to club me to death. The stuff that they're talking about, although it's new and cool, I'm kind of a closet historian. Actually, I'm not a closet historian. I love history. A lot of the stuff is old. Like how hot the sun is. The sun, it's 10,000 degrees on the surface. That's not new, but they keep recycling it in a better way because every year there's a new crop of little kids that's fascinated by that. And it's like every little kid is frightened, like doesn't want to die. But like people tell them, the sun's going to vanish in 5 billion years. And that scares people. And that makes them watch it. It's like an inherent kind of interesting thing. So they have the better TV shows. I want us to have as good of TV shows.
How can we do that?
We've got to start talking to people and getting the word out.
So here's a space virus story, factoid.
Go
If
ahead.
you took all the viruses in the oceans, there are 10 to the 30th virus particles in the ocean, and laid them end to end, they would stretch 200 million light years into space.
That's far.
It's very far, past the nearest galaxy, for
Yeah,
sure.
I got one too.
What's yours?
Yeah. Okay. When we're still doing it, but the work on the state microbe, right? Streptomyces griseus, it's an actinomycete. Professor Evely said, he scratched his head. I remember there's a lot of this stuff in the soil. And I think I remember when I was a graduate student, I did some calculations to find out how much there is. So he called somebody at the U.S. Department of Agriculture, and then they looked, and it turns out that per square foot of soil, just a square foot, an inch deep, there is from 80 to 240 miles worth of actinomycetes threads, because it's a filamentous bacteria, right? That's a whole hell of a lot of bacteria.
Yeah.
Now, if you multiply that by the square surface of the Earth, and this is just actinomycetes. This is not all the E. coli and Pseudomonas and all the other stuff in there. It's just the actinomycetes. I went and said, well, heck, I'm going to, multiply that by the surface of the Earth. You get a strand of bacteria that will get you from one end of the galaxy to the other. That's a lot of bacteria. I forgot what the number is, but I wrote it down. That's a lot.
It's cool.
Something like that can inspire kids.
Yeah, I think those kind of measurements microbiology measurements are important, and I use them to start off talks, as I'm sure you do, because that grabs people in. But you have to sustain it. You have to sustain it and not get into details. And you know, that's part of the problem that we have, is that we're trained about
trained
details.
to be detail-oriented. Yeah.
We have to get away from that. But I agree that I think scientists need to be the spokespeople for science.
Yeah.
You know, other people write about it and so forth, and they do well, but it's us with the passion, and so it's our job to do it.
Yeah, and the passion shows through.
For sure. So let's talk about the New Jersey State Microbe.
Yes, sir.
You have a shirt.
I have a shirt,
So tell us the name of it.
The shirt, well, we had these Max Hagbaum, the department head at Rutgers, had these shirts done up for Rutgers Ag Field Day, Rutgers Day. It's a big thing every day at Rutgers University. It started off as Ag Field Day, which was a small event, and then the university said, well, let's make it big. So they shut down everything and invite everybody back. So it's Alumni Day, it's Ag Field Day. All the ag students get to show off the cows and chickens and pigs that they raised during the year. It's a really cool event. So they had the T-shirts made that say Streptomyces griseus, New Jersey State Microbe. And the hashtag I came up with is hashtag NJ Microbe.
Now, why Streptomyces griseus?
It's a beautiful and compelling story. Streptomyces griseus was actually first discovered in New Jersey in 1915, just as an organism. In 1943, Albert Schatz was doing a systematic study of soil microbes under Selman Waxman at Rutgers, which was actually at the time called the New Jersey Agricultural College or the New Jersey Agricultural Experimental Station, systematically looking for soil bacteria that produce antibiotics. So in October of 1943, he pulled the culture out of the ground and he did antibiotic sensitivities on it, and turns out it made an antibiotic that would kill gram-positive and gram-negative organisms. He went and isolated it. The organism was Streptomyces griseus. It was the second time it was found. The isolate produced streptomycin. And streptomycin they did all the workup on it, all the isolation, and it was the first antibiotic effective against tuberculosis, and it was the first broad spectrum. It was effective against gram-positive too, first broad spectrum antibiotic in the U.S. And it was a proud moment. It was the first anti-tubercular. It went on to change the world because prior to streptomycin, there was no effective therapy for tuberculosis. And in fact, doing the clinical trials for streptomycin had the first placebo-controlled trial in the history of medicine. And they went, and I think it was, I can't remember the physician's name, I will later. They compared traditional treatment for tuberculosis, which was rest and fresh air, versus getting a daily injection or two of streptomycin. 95% mortality in the treatment, in the placebo group, a lot of survival in the treatment group. And from there, it was a great.
No, that's a good microbe for New Jersey.
It is.
But we should say it's not yet the state microbe, but you're pushing to make it, right?
I'm pushing to make it.
So why do you want to do that?
A lot of reasons. And I would start by saying that it provides an opportunity for us all to talk science to the rest of the world and to talk to science to our legislators. And it provides a way in to start a scientific and medical dialogue with people who you normally would not be talking about such things with. That's one. We're both from New Jersey. We often don't have a lot of things we can be proud of in the state. We have really nice beaches. But there's a lot of things that people are annoyed about a lot of times. The microbe is something that we can all get together on and say, this is really cool. New Jersey made this. We made the world better because of this. We saved millions of lives. We put thousands of people to work, created the entire antibiotic and pharmaceutical industry, started, kind of 1943-ish with the production of streptomycin.
Now, do other states have state microbes?
Interesting story there. Yes. Oregon was the first to actually pass state microbe legislation. Their organism of choice was Saccharomyces cerevisiae, otherwise known as brewer's and baker's yeast. And the cool story there is that Oregon is the home to one of the world's largest craft brew industries. They produce $2.5 billion a year in revenue for the state, and they're enthusiastic. If you think about how easy that is to sell to the government, sell to your legislators, it's easy and to sell to the public because almost everybody drinks. Beer is a happy thing. So it's easy for craft brewers to get on the phone and say, hey, Senator, vote for this legislation. And it's easy for people from the bars to call in and fill out cards and say, hey, vote for this. It's good because it's a big, happy thing. And it's also used, it's baker's yeast. And it's also in genetic engineering and all the gene splicing kind of work that was done with Saccharomyces. And just tangentially, it's like in doing some of this work, it's like I asked myself, well, how much bread is made every year from baker's yeast? And I came up with there's a baker's organization, and it's something like 3 trillion metric tons of rolls and bread are made every year. And it all comes from it's a microbial source. I'm like,
sure.
Wow. I mean, that's another one of those like infinitely long, like how big is the universe? Well, if you laid every roll end to end, you'd get pretty far too. So that was Oregon was the first one, and I congratulate them on that.
How long ago was that done?
I think 2011, 2013.
Okay.
The first one to try was Wisconsin.
Mm-hmm.
They tried with Lactococcus lactis because it's involved in cheese production. And Wisconsin is America's largest producer of cheese. They have like 700 varieties of cheese. Mm-hmm. They produce more cheese. I don't want to screw up the facts, but like they produce more cheese in Wisconsin than all of Europe does. It's like, it's like how much is their income? It's like $3 billion worth of cheese comes out of Wisconsin. Huh. So it's a big thing. That got through the legislature. Sorry, it got through the assembly, and then it kind of got killed. It didn't move forward. And the story, from what I understand, I talked to people who were in Wisconsin at the time, and it becomes one of these science or non-science issues. They all say that, the governor, I never met the man, I don't want to throw stones, said the governor at the time was like anti-science. He was not a science guy. So they let the legislation waste away. The funny and outrageous part of the story is they didn't have the personal strength and integrity and will to pass microbial legislation, right? But shortly thereafter, the entire state of Wisconsin, the legislators, the people, everybody got together and they voted with a single mind and a single purpose to have an official state pastry, the Kringle. So they could see that, okay, we love the Kringle, we're going to have it, and we're going to vote for it. And it's like a tough pastry with almonds on it. So they said, yeah, we're going to do this. But they didn't have the internal strength to say, oh, we're going to go do a microbe. And it's like, wow. And it becomes like maybe microbe, I'm trying to rationalize how that happened. And I'm thinking maybe it's because the legislators didn't have good science teachers.
Could be. Sure.
Why else would you do it? Or maybe that the bakers have a better lobbying group than scientists do. I don't know.
So could you make a case for other states having microbes? What about like California? A lot of wine, right? What would you do for that one?
Well,
I don't know if there's one microbe you could point out, right?
I'm trying to think of that. I mean, certainly because you got to ferment wine, any one of the yeast would be good. And talking about state symbols in general, it's like just because Oregon picked brewer's yeast doesn't mean somebody else can't.
Yeah, sure.
Because like milk is the official state drink of like 10 states.
I didn't know that.
Yeah, I didn't either. I'm picking up all this state symbol trivia because there's people that run websites on state there's a lot of repetition. A lot of people that have there's state dances like the square dance is the official state dance of like another 10 states. So there's all these layers of stuff.
Got it.
But I was talking to some guys from Texas this morning, and they're like, yeah, we need a Texas organism. And I'm trying to, we're just talking back and forth. I'm like, well, there's something called Fraccibacter, which lives in fracking fluid. Mm-hmm. So that would be tough. And but they were thinking, we need something big.
Because it's Texas, right?
Yeah, because it's Texas.
Yeah,
and so they're going to brainstorm with some of their friends and see if anything really, really huge grows in Texas.
Well, the huge underground mycelia, fungal mycelia.
There you go.
Right? Some of them are 1,000, 2,000 miles in diameter.
That'll
I understand.
work.
Now, if you would let
viruses,
viruses,
in Texas.
yes, they're mostly up north. If you would let viruses into the act, you could name a giant virus for Texas, but you don't find it there. So it's got to be in the state, right?
Yes. Yeah, I think that's the only requirement. And the reason I picked microbe instead of bacteria, because other states can do this, and they're like, what if it's an aquatic state and they have a really nice algae?
Yeah,
to me, algae is microbial.
Sure.
To me, a microbe is anything that's you need a microscope to see. You know.
Now, what's the process for doing this, and where are you in New Jersey in that?
It's a long and convoluted process. Most of it involves a lot of luck. The process started, actually, I had been in communication with Doug Evely and some of the other professors at Rutgers. And we came at it from separate directions, and we came up with the conclusion that Strep griseus would be a cool microbe. I found out about the idea of a state microbe and doing some other research, like from a periodic table, and I saw Oregon has a state microbe. I'm like, okay, so I just filed that in the back of my head. And I said, well, what would be reasonable choices for New Jersey? And my first thought was brewer's yeast, because we have the huge Budweiser plant, Strep griseus because of Streptomyces, and the other thought was Azotobacter vinelandii because it was discovered in Vineland. It fixes nitrogen, and that's really important for growing crops and everything else. And then I said Strep griseus, and then I was talking to Doug, and he says, well, we've actually been having an unofficial poll for the past couple of years. It's up on their website that I knew nothing about. And he said, well, we gave it two choices. It was Strep griseus, Azotobacter vinelandii, and Thiobacillus thioxidin. And he says, when the public votes in, Strep griseus wins by a 3-1 margin. And he says, most of our faculty here and everybody we talk to says Strep griseus. So I said, okay, well, it's confluent evolution. We all agree on it. And I just funneled it in the back of my mind, and it was like a snowball in my head, and it just kept getting bigger and bigger. And I was like, I got to act on this. So I put together, and I knew that Doug had worked on like getting it. He tried to get it through the legislature, but I think he sent it to Washington as opposed to Trenton. He sent it to Frank Pallone, I think, years ago. He said, we should have a state microbe, and Frank didn't respond at all, which, well, politics is a weird thing that I found out. So I said, all right. So I just kind of took it on myself to do, because I know some of the political people from other things that I've done. So I came up with, you take all the, and I'm speaking with my hands here, you take the yards of information that academics are used to dealing with, page after page, and theses and things that are really, really thick, boil it all down to one page of bulleted points that you can talk about in a minute or 2 minutes. And I had that, I prepared that, and I knew I was going to be at a meeting with a bunch of politicians, and it's like I had them in my pocket. And I walked up to a couple of them. I told, hey, we should have a state microbe. And they're like, yeah, go away. But we're lucky because the senator he used to be my senator, but now he's the senator for the district next to me, is Dr. Sam Thompson. He has a PhD, I think, in medicinal chemistry. And I gave him the pitch.
State senator, right?
State senator. Yes, state senator, not Washington senator. Because the state senators are the ones who are responsible for what's going on where you live.
Right. And
they represent you, and you should know who they are. And if you don't, you should. You really should. Because they're their interface. You're their interface with the government. They represent you, and if they don't, you got to vote for somebody else. So anyway, I gave the pitch. I handed them the proposal. I gave it. So anyway, you take all the stuff, you get it down to a page of bulleted points, and then you hand it to him, and then you give your 30-second elevator pitch. And he scratched his head and said, "That's a really good idea. I'm gonna submit that." And a week later, he got it. It was there. It was part of the record.
So this goes to the state senate.
Well, it's the state's the first. Yeah. So first, the process is that you find a sympathetic senator or assembly person. They write it up. I didn't write up the bill, so I don't even think Senator Thompson wrote it. There's like they have their people.
Yeah, their staff.
They have their staff. So it got written up, submitted. Like, and if it got a bill number, I think the first one was S 1729. It gets it gets worded. It has a bill number, and then it's assigned to a committee meeting. It's an open committee meeting, and it goes up for review. There's like 4 or 5 senators on it. And then we went down and testified before the committee, Max Haglund, myself, and Doug. And we said why we thought it was a good thing. And we got the committee to vote yes on it. And the cool thing about the committee meeting, it was on Robert Koch's birthday.
Yeah,
so
great.
It was like an omen, So we did that. The committee voted unanimously, and then it goes to the full Senate at some unknown point in the future. And the Senate voted unanimously for it too. So it was like one day, everybody in New Jersey agreed on something that was 4/100,000th of an inch in diameter, and they agreed. And I was like, wow.
This is politically neutral. I guess that's why, right?
Right. Politically neutral, and it's a happy thing.
Yeah.
And then the assembly is the other side of the story. What I did there was, because I knew that as soon as Dr. Thompson agreed to do it, I said, I said, I know how the system works. We need sponsors. We need co-sponsors. We need all this other stuff. Yeah. So I sent the proposal, and I sent emails and hard letters, snail mail, to all the people in the assembly and Senate, the rest of the Senate, who were graduates of Rutgers. I figured, well, it's a good Rutgers connection.
Yep.
And that's like 25 or so people. And I got one positive response. And it was from Assemblywoman Annette Chiano from like Elizabeth area. Annette has a distinction. She's in fact born on the 4th of July, which I think is really cool. So she looked at that. She looked at the proposal, and they said to me, "This is a really interesting proposal. But tell me, would you be, if I submit this, would you be willing to go and talk to students in my district? Would you be willing to go and talk to community colleges and high schools in my district and talk about this piece of history from New Jersey? Because I think this is an underserved area. Nobody but you microbe guys know this, and this is important for the history of Jersey. And telling students this may open up career paths to people who would otherwise not be exposed to it." And I said, "Well, yeah, you're going to give me a chance to be on stage and talk to people?" And she said, "Yes." And I said, "Absolutely." So she submitted her bill the next week, and they're mirror bills. And that's kind of the process. So anytime the bill comes in, it has to go through a committee. Last year, the Assembly bill was assigned to a committee that unfortunately didn't meet. Not that anybody was mad at us. It just, that's how things happen. Because my analogy is there is in fact a black box in legislature. Yeah, it's between us and the people that are elected, and also between the elected people and us. There's like stuff that even they don't control, like scheduling of when the bill is going to get voted on. I've asked like Senator and Assemblywoman, "Well, when are you guys going to vote on it? When's the committee going to be scheduled?" And they're like, "We don't know because we're not really in charge of it." So
right now you're waiting.
Right now we're waiting for the second coming of the Senate bill. But because it passed 100% last year, we anticipate no problems with that this year. And the new committee for in the Assembly is the Science, Technology, and Something or Other Committee, and it has a PhD nuclear physicist on it from Princeton. It has a physician. He's an MD, JD, former Army captain, so it's like impressive credentials, and an assemblyman, and a couple other more academically oriented people. So we think that once it's in there, it can get scheduled there, and we'll get it through there. So we're 100% positive it's going to go through. It's just a matter of timing.
Okay. And that's going to happen this year, I guess, calendar year?
I hope so.
And then when it does, what do you do?
Oh, once it's done? That's a really, really good question. It's like, oh, when you hit the lottery, what are you going to do? I haven't carried it that far yet. I think we'll have a big party. It would be really good if it happened this year because I think it's the 75th anniversary of Streptomyces. I don't know. I think we could get a road show together and go off and talk about Streptomyces and Strep griseus to people. It certainly would mean that the state needs to update their website because now we've got another state symbol. Yeah, and like all those what are they, social studies classes or civics classes that still may or may not exist in school systems?
Yeah. Well, maybe you would use it as a teaching tool now. You can go out and say, look, we have this New Jersey state microbe, and people will pay attention, whereas before they might not. Yeah. And then you could teach them about it, why it's important and why it's cool and so forth.
Yeah, it's absolutely a teaching tool because it's like, unfortunately, even with, and here's my other soapbox about astrophysicists having a cooler life than us. When you look at STEM, STEM, science, technology, engineering, math, When I look at that, it's like science teaching except for microbiology.
Yes, right.
It's like when I talk to science teachers, and I'm a member of the National Science Teachers Association, and I see what gets posted on the board, I don't see any microbiology in there anywhere. And it could be because they're afraid of liability issues. It could be for a lot of things, but you really don't need wet labs to tell people about bacteria. And it's like for anybody that graduates high school, you graduate high school, you go into different fields. They've never had it. And you grow up being afraid of everything because all you hear is the word germ. You don't hear nitrogen fixation. You don't hear cellulose degradation. You don't hear, all the good things.
Yeah.
Cheese making, beer making. And it's a shame. It's a niche that needs to be filled somehow.
So I wish you luck with that. I hope it works.
Thanks.
But if you don't get it this year, will you keep trying?
Absolutely.
All right.
I'm stubborn.
Now, the other thing you do to teach people about microbes is you have, here on the table, we have Dr. Warhol's periodic table
of microbes.
And an accompanying book.
Yes, the small guide to small things.
So tell us, what is this periodic table of the microbes?
Periodic table of microbes is my noble attempt to educate the world about bacteria, microbes. There's several ways I can introduce the story as to how it came about. But the idea is that if you think about the periodic table of elements, it's the single most iconic thing in all of science. It's in every classroom from maybe third or fourth grade on.
College too.
It's there.
I went to see my son's college classes, and it's on the wall.
Yeah,
it's amazing.
Yeah, it's a beautiful thing. It's everywhere. So it's like it's in our cultural DNA to see it and to know it's there. And everybody knows, it's a periodic table of elements. So people know elements. They know chemistry. They're at least familiar with it. I looked at it and said, well, it's only been used for chemistry. We need to be able to do something else with it. And I said, well, it really hasn't changed for 130 years either. This I could do something with that. So the idea was that because people were familiar with the periodic table of elements, and my philosophy of education and training is that you go from something familiar to something unknown, and it's a progression rather than just throwing a bunch of stuff at people and hoping it sticks. It's like, so you start from the familiar, you move to the unfamiliar, and it makes it comfortable. Because they've seen this, you'd be able to, get into it easier. So basically what I did was, in the nerdiest and most obsessive-compulsive way a person could possibly be, I removed all the elements. I replaced them with microbes whose names could be approximately. Yeah, you could try and give me a quiz. I replaced all the elements with bacteria whose names could be reasonably approximated by a chemical symbol. So H instead of being hydrogen is now Haemophilus. He instead of being helium is now Helicobacter, and so on for 118 organisms. And I also made a key, just like on the real periodic table, so that when you look at it, you could tell, well, is it gram-positive or gram-negative? Mm-hmm. Does it live in the soil? Does it live in the water? Is it an extremophile? Is it a pathogen? Is it a food organism? Is it one or more of them? So there's a little key to all of those.
Yeah, shape too, right?
Shape too, yeah. Rod spirals, helices, you name it. So it's like a really quick study.
It's pretty cool.
Thank you.
I think you put this on the wall of a classroom, and every day the teacher could say, okay, Johnny, pick one. Let's talk about it.
Absolutely. That's the entire idea.
And to help that, you have a book that goes with it.
I have the book. Yeah, because what happened was I did the periodic table first as a visual thing.
And you're selling this, right?
Yeah, it's available on my Etsy site, and it's also available if you read the book. There's links to the Etsy site in it. So Etsy is like Warhol Science on Etsy.
It's also on Cafe Press, too.
Cafe Press, you could buy T-shirts and whatnot. We'll get the plug in. I should have worn my Warhol periodic table microbe sweatshirt, but I didn't.
Must be compressed in there on the front, right?
That's kind of the problem. Yeah, I got to do them one at a time.
Cool.
So you just
you sent me a couple of these. I think they're very cool. I got one in my office.
Thank you.
On the wall.
So immediately after I did microbes, I did viruses and I did parasites.
Are those for sale also?
Not yet. No, because I didn't print them in bulk, but if anybody wants one, just shoot me an email or a tweet and I could certainly print them off and send them. But after I did the poster, I realized that people who look at the poster didn't hear the voices in my head that are saying what it is about each of these organisms that's cool unique or
Right.
has a story to tell.
Yeah, because the name is not enough, right?
Right. And just looking and seeing that, like, oh, it's a gram negative or it's this and, whatever. So I had to write the book to explain to people what was cool or interesting about them. And a lot of them, like the first 8, I think, are pathogens. And then after that, it becomes more diverse. And pathogens is just because you hear them every day. So Haemophilus is the first one, and anybody who has kids knows they got to get their kid vaccinated for Haemophilus. And if that's all a parent or a person out there takes away from this, good. You've heard the word Haemophilus. But then you start getting into the weirder and cooler stuff. And I was just talking to some people downstairs, and it's like KR, Krypton, Kurthia. What's Kurthia? I've never heard of it. And I'm like, oh, the Kurthia story is when they found that 20,000-year-old mastodon in Siberia, right? Mm-hmm. They were able to culture live Kurthia from its stomach. I'm like, that's amazing. That is one of the coolest things I've ever heard. Cool. And the only other place you're going to find Kurthia other than spoiled meat is in the mouth of a Komodo dragon. And Komodo dragons have the nastiest oral microbial flora on the planet. As far as I know, they don't make a venom, but when they bite you, it's so polluted and contaminated that everything just grows and it causes a polymicrobial infection in your body, and you die. But it's just neat.
Yeah. And
each of the organisms in the table, 300 words or less, and I did a word count, and so at the end of it, it's 300 words for each organism, and it's stories and it's relational. So it's not just like talking about like DNA sequences or, this ferments that and this ferments that. And this is how you're going to key it out on an enterotube or an agglutination test or something. It's stuff like that.
So the book can be used by teachers.
Yeah.
A kid says, okay, are you? And the teacher can open it to that and say, okay, here's some cool things about Rubrobacter.
Right.
And by the way, these abbreviations match the original periodic table.
Absolutely. Right? That was the hard part.
Okay, you got H, Libe, NAMG, all the way out to the rare earth elements. Yeah, it's very cool.
Yeah. Thank you.
And it's colored as well in the same way.
Yeah. And there's a lot of wordplay that goes into it. One of the proudest, pride is one of the 7 deadly sins. One of the things I'm proudest about is when I started on this, one of my heroes in the world out there is James Burke. He's a noted science historian. He wrote Connections 1, Connections 2, Connections 3. He had a BBC TV series. He had a series called The Day the Universe Changed. And he's really big on finding the historic connections that lead you to somewhere. And when I started to write the book and I had a draft, I found like his contact in the U.S. and I said, hey, I just wrote this. Could you give it to James Burke to review? And he goes, okay. And then like a week later, I was on my wife, I was the guest for my wife at a meeting she was at, and we're ready to go to dinner. And I get this email coming and it says, hi, this is James Burke. I just read your book. I'm like, oh my God, this is the best thing that's happened to me. And he says, and his response back to me is, I rarely enthuse, but this is brilliant. And he said, I love this. I'll finish reading it over the weekend and I'll get back to you. And I was like, wow, this is like validation. This is my first time out doing this. And it's like, this is my hero. And so he said, yeah, my favorite, because there's a lot of weird stuff in there. You live in New Jersey. You have in your basement or garage, you have those mutant camel crickets.
Yeah, of course.
Okay. There's people who isolated there's people who study mutant camel crickets, and they isolated bacteria that are only found in those weird camel cricket, and like they're in there somewhere. So it's like stories like that, like
Do you have a favorite?
I have a couple favorites.
Okay, what are they?
I really like the Modestobacter story. Now, who studies Modestobacter? Not many people. But I like Modestobacter because you would think it would be like
101.
101. you would think that it would be the mascot for the band Modest Mouse or something like that, But Modestobacter or would be Modestobacter is actually named because it has really modest food requirements, right? It requires almost, as opposed to like, I used to work on pathogens and they require really rich media, right? Modestobacter requires almost nothing to live on. And the reason why it requires almost nothing to live on is because it lives on the Antarctic ice shelf.
Yeah.
It lives in the place where forever scientists went and they said, this land is sterile because it's 200 mile an hour winds. It's 180 degrees below zero. It's too cold. It's too inhospitable to live. And they tried to culture stuff and nothing grew until one day some really, really intrepid microbiologists went there and they said, no, there's no such thing as an unfilled niche. And they went and they found that Modestobacter, they found Modestobacter and other organisms like it live there. And I think they're called cryptoendoliths or something. So they actually live in, on, or among rocks, right?
Yeah.
But it grows really, really slowly.
That's right. Uses gases to grow, I think.
Yeah. And it's like...
We talked about that on a recent TWiM.
Really?
Yeah, there's a paper came out recently where they reported the results and really uses the gases to live. You're right; they don't divide very quickly.
They don't divide very quickly, and it's like,
enough to maintain them, basically. Right?
Yeah, and the story becomes even crazier because I'm like thinking, all right, like even if you wanted to study this organism and go take cultures, you really can't. You need to get special permission from like the UN to go there and try and culture it because it's in these places where you're forbidden to go. And when you go, it's like they don't even want you to land the helicopter because the helicopter is going to disturb the earth. They don't want people walking because the colonies take 10,000 years to grow. So it's the kind of thing like you got to hang off the edge of a helo, take your loop and scoop up some dirt.
Yeah.
You know, it's like, wow, what a cool story.
It's a good one. Yeah. I mean, these are just some examples. You got another favorite? You must like Streptomyces, right?
I like Streptomyces. It has a good stories, but it's not like super humorous.
Yeah.
Weissella is good. The example I use in there is it's the Kimchi organism. It ferments. It ferments at zero. If you're correct, and then I tell a story about kimchi. Kimchi went on the space shuttle. It produces massive amounts of vitamin C. It's like the national food of Korea.
Mm-hmm.
Multivitamins and minerals and other stuff like that. What was Modestobacter? I'm looking upside down. Well, Listeria. A lot of what I do is wordplay, like Listeria. It's like it's not an OCD disease of people who make lists. Yeah. It's not about people who like waltzes. Listeria is an organism that causes food poisoning, but it's not just the kind of food poisoning where you go out and you run to the bathroom and you crap your brains out or you throw up. Listeria will go and it will cause meningitis and it will kill you. And Listeria is responsible for something called the Great Hummus Recall of 2015.
That's right.
There was a hummus manufacturing company somewhere around us where we live, and it was like 70,000 gallons of hummus were contaminated by Listeria, and they had to like recall it all. I'm like, what a title for something! The Great Hummus Recall of whatever. Other favorites, Helicobacter has a cool story because that's it causes. In certain people, it causes ulcers. Mm-hmm. But if you remember all those scientist movies we used to watch growing up as a kid, the black and white ones, and talking about like the scientist experimenting on himself, that's a perfect example. The man who discovered it says, "I think this causes ulcers, but I have no proof, and the government won't let me do a trial, so I'm going to drink some." And he drank some, and he got sick.
You bet.
Oh, what's the good one? I like saying that thermos, which is way down at the bottom, it's like number 69, thermos. Without thermos, there would be no CSI shows on TV. There'd be no CSI, there'd be no NCIS, there'd be no any of those other shows.
Thermus aquaticus.
There you go. Exactly. You got it. The reason being that thermos is where Thomas Brock he found the organism, but it's got Thermus aquaticus. It runs at high temperature. All the enzymes in it run at high temperature, including the DNA polymerase.
Right.
And that is the basis for all polymerase chain reactions and all the CSI shows. So that when like Gibbs comes in and says, "Maggie, get me DNA results on this," it's because of that organism.
Mm-hmm.
And what was it? It was voted, like Taq polymerase was voted by Science Magazine as the molecule of the year in 1990, whatever it was.
Very cool. Yeah. Now the periodic table of the viruses and the parasites, they don't have a book yet. Right?
Not yet.
Are you working on it?
I will as soon as I get this one off of my.
And you said also you're working on a larger guide for the microbes with more words, right?
More words and more pictures. The challenge is the current thing is just the icons because that took forever to do as it is.
Right.
I really want pictures. of each one of them because that enhances the story. But if you think about there's 120 organisms, 118 organisms. If you do 3 or 4 photos or illustrations for each one of them to make the book more interesting, that's a lot of layout time.
Yeah, of course.
It's a lot of typesetting and layout and permissions. And even if I don't get the permissions, it just still expands it to a really huge project.
Got it.
So if I get a lot of positive feedback on this, I'll certainly do the more colorful and interactive one.
So in the book, in the beginning, you have a nice introduction.
Yeah.
Where you have the top 3 microbes in different categories.
Yes. The stinkiest, the loneliest.
The hottest, the coldest, right?
The hottest, the coldest. And actually the inspiration for that was from my son. My son is not a scientist. He is he's a video editor, producer, that kind of thing. And I had him proofread, or I had him read the first draft of the book. And he said, this is really good, but you need, but you got to make it more, you got to hit something up front that will attract people. He says, how about doing the top 10 or the top 3 of everything? I'm like, all right. So I took my son Jonathan's advice, and I have, the stinkiest, the smelliest, the hottest, the coldest, the deepest, the ones named after men, the ones named after women.
Yeah, that's cool.
And it's a hook.
Yep. The other thing you do is you say you're not going to use italics. Why is that?
Good point. Actually, Doug Everly pointed that out when I did it. He says, you don't have anything italicized. I'm like, well, yeah, there's 2 reasons for that, maybe 3 reasons for that. First is that I did the table first, and italics don't look really good on a table.
Yeah,
it would not work, and I wanted to emulate the look of the periodic table of elements. The second is that italics don't really work on ebooks. But the third, when I thought about it more and more, is that italics sets up this – italics in Latin words, it sets up this distinction between us who are scientists and them or the people who are going to read it. And it just creates this what I perceive as a barrier to learning. It's like when we look at it, we automatically know it's an organism. And probably they would too, but because it's in Latin and it's in italics, I really honestly think it's a barrier for people to try and understand what it is. And I can understand, like, for formatting, if you're going to put it in a journal, sure. If you're going to, a textbook for the field, sure. But for my wife, for my son, for, people who watch TV, it's a barrier, and the names themselves are hard enough. It's one of the things I think I talked about at Seton Hall was, as biologists and microbiologists and virologists, we're dealing with things that are really small and really precise and really foreign to most people, and they don't have common names. So, like when you talk to fisheries people. And again, my favorite, the Hawaiian triggerfish. Okay, it's the Hawaiian triggerfish. And people will say, oh, it's a triggerfish. They'll get that. And if you're a fishery scientist, it's the Rhinacanthus rectangulus, which is stranger. But if you're Hawaiian, it's the Huma Huma Nuku Nuku Apua.
Yeah,
right.
Right? That's right.
Having a common name makes it easier for people to understand. Having it not in italics makes it easier for people to understand.
Got it.
And I was just trying to make it less of an us versus them thing and more of an us thing.
Another thing I like is you say, don't call them germs.
Don't call them. No, that's the worst thing. When the state microbe stuff first came out, I don't know who talked to the press or who gave a press release, but the first press we got was awful. It was somebody from Philadelphia papers. Oh, New Jersey's getting a state germ. Isn't that stupid? Like, no, it's not a germ. It's a microbe. It's a bacteria. It's germs are, like none of us use the word germs. Like you could say it's a pathogen or it's something, but especially the state microbe is not a germ. It's a beneficial soil bacteria. But yeah, germ is disparaging. It's like using the N word on a bacteria. It's like, call it what it is. It's not a germ.
I agree. But the press tends to call them germs, and it's
not good.
Unfortunate.
It is.
I always rail against it, so I'm glad to see you did as well.
It truly is unfortunate, and it's like press education is something that we should all advocate for too.
Yeah,
because they were the journalism majors.
Well, if you need help with viruses, I'm happy to help you out.
Oh, I'm looking forward to it. Viruses have cool names. Did you look at the ones on the virus chart? You can see the strawberry crinkle virus.
Wonderful names.
The beluga whale virus. The crocodile pox.
We should, you have microbes, you have viruses, parasites. Of course, we have a podcast in each area, so maybe we could do a tie-in.
Sure.
We could do some giveaways, and then maybe people will pick up on it.
I was talking to a mycologist this morning. He goes, you should have one with fungi.
Yeah, you should.
I'm like, okay. Yeah.
And of course, we have on our This Week in Parasitism, Dixon Despommier, who's an expert. If you need some help there, I'm sure he'd be able to help you.
Actually,
as well.
I just met through connections somebody who works at CDC in the parasitology department, and she says, I have this periodic table of parasites. So I sent them one. So right now, somewhere in the CDC, there's a periodic table of parasites hanging up.
How is all this doing? Do you have an idea how the poster's doing, how the book is doing?
No. The book just came out last week, so I don't have
Too soon.
I don't have any sales things. The posters they sell mostly because it's not as broadly as I wanted to. Right now, it's mostly nerd gifts at Christmas time. My first sale was actually an international sale. I went to some guy in Australia. But it's been like all over the world, actually, people have bought them. But what I want to try and do is get it more mainstreamed so that they'll be used in classrooms and so that people will say, hey, there it is.
And that's part of why you came to this meeting, right?
That's part of why I came to this meeting.
Right.
Yeah, definitely.
All right, that is a special TWiM here at ASM Microbe 2018. You can find TWiM at microbe.tv/TWiM. And, of course, if you have a mobile device and you listen to podcasts, just subscribe. It's free and you'll get every episode. And if you have any questions or comments, TWiM at microbe.tv. And, of course, if you like what we do, please consider supporting us. You can go to microbe.tv/contribute. We have a number of ways, including a Patreon account. We'd appreciate your support. My guest today has been John Warhol from the Warhol Institute. Thanks, John, for joining me today.
Thank you very much. It has been my pleasure.
Now, people can find you. You have an Etsy shop. We said a Cafe Press. You're Warhol Science on Twitter.
Right, at Warhol Science.
You have a Tumblr, right?
Tumblr is Microminutes at Tumblr. That was a carryover from my first YouTube account, which was Microminutes, which I started many years ago to do micro instruction in under a minute for the YouTube crowd.
Ah. Does it still exist?
It still exists. I haven't updated it, and it's an example of my not doing my homework because my daughter was really into YouTube when she was in high school, and I went to the YouTube conferences with her, and there were people in the educational division doing like, oh, here's minute physics, here's minute chemistry, here's minute math, and I said, okay. Microbiology is cool. We need to do minute microbiology.
That's nice. It's a good idea.
But what happened is I didn't know that nobody taught micro in high school. So all the people who do minute chemistry, minute math, minute physics, they have a pre-made audience there because all those kids need help with their homework, right?
Of course.
And I was spending hundreds and hundreds of hours doing the videos, and it ended up that like I enjoyed doing them. I'm glad that I did them. But it's like you said this morning, you got to know when to stop.
Yeah, right.
Because it was just hundreds of hours. Yeah, but they're there. People could find them.
I'm Vincent Racaniello. You can find me at virology.ws. I want to thank ASM for their support of TWiM and Ray Ortega for his technical help and Ronald Jenkins for his music. You can find his work at ronaldjenkins.com. Thanks for listening. We'll see you next time on This Week in Microbiology.